Alright, so half angle identities. I'm not going to show you where these come from. I could if you are interested. They really just come from the double angle identities. I'm just going to give them to you and let you write them down. So that is that last empty tab on your flip chart. There are 5 formulas. Let's look at some examples. Again, these formulas, like everything else, they're all going to be on that formula sheet. You don't have to memorize these formulas, you just have to be able to use them. We do have 3 options for tangent, so we'll just pick whichever one we think would be easiest for the problem we're on. So A, find the exact value of sine of 22.5 using the half angle identity for sine. So I've told you which formula we're using. Let's start just by writing down our formula. So the half angle identity for sine. Sine of a over 2 equals plus or minus the square root of 1 minus cosine A all over 2. We are using this to find the sine of 22.5. So the question is, what is my A? 22.5 is the same as what divided by 2? 45. So A is 45. So to find sine 22.5, we are going to plug a 45 in to this formula. So we get plus or minus the square root 1 minus, what is the cosine of 45? Divided by 2. Is it okay to leave a fraction in a fraction?
No.
How can I get rid of that? The denominator there is a 2, so let's take everything times a 2. So we have plus or minus square root of 2 minus radical 2 over 4. One final step. First of all, we need to decide, is it positive or is it negative? Yeah. Our angle, this is to find the sine of 22.5. What quadrant is 22.5 in? 1. So should it be positive or negative? Positive. Alright, we could do this as the square root of the top and the bottom. So I can't do the square root of the top. The square root of the bottom, the square root of 4 is 2. So my final answer is a positive square root of 2 minus the square root of 2 all over 2.
So you can leave a square root instead?
Yes. And on these, using these formulas, most of the time you will have a square root and a square root. They aren't going to be pretty. Questions on that one? For each example I have for you today, there are really only 4 types of problems. I've got an A and a B for each type of problem. So if you want to see it, we'll do it. If you guys don't want to see it, I can skip it. So it's up to you. My next problem is doing the same thing with the cosine of 15. You want to work it?
Wait, do they get more difficult?
I mean, the example 1A and 1B are the same, essentially, just using a different formula. Do we need 1B? No? You're confident you could do that? Okay. Let's look at example 2. I'll give you a second to write it down and then we'll talk about it. So I've already told you which formula to use. There are 3 options for tangent. Any of the 3 options will give you a correct answer. This time I'm just going to use this one. A lot of times with your tangent formulas, if you look at them, one of them involves the square root, the other 2 do not. If I can, I usually avoid the problem with the extra radical in it, but you can't always. So you just do whatever you need to there. So tangent of 75. we have to figure out what A is. So 75 is what divided by 2?
150.
150. 150 divided by 2 gives you 75. So these things have to be equivalent. So my A value here is 150. Okay, so let's talk about the 150 degrees for a minute. What quadrant is that? Okay, reference angle. So now let's evaluate. In the second quadrant, is sine positive or negative? Positive. What is the sine of 30? 1/2 over 1. In the second quadrant, is cosine positive or negative? Negative. Cosine of 30? Take everything times 2 to get rid of the fraction. So 1/2 times 2 would be 1 over 2 minus radical 3. Right. I've been fairly lenient on these with radicals in the denominator, and I will continue to be a little bit lenient on these if it's multiple terms. But if you wanted to get rid of it, like your book has some matching problems, let's say you're trying to match it, what would you have to multiply by? 2 plus radical 3 on top and bottom. So you get 2 plus the square root of 3 over 4 plus 2 radical 3 minus 2 radical 3 drop minus the square root of 9, which is 3. 4 minus 3 is 1. So finally it's just 2 plus radical 3 if you took it all the way. Okay. So I have given you cosine of s, and that's all. We need to find sine, cosine, tangent of s over 2. So let's start by writing out our formula. Sine of s over 2 would equal plus or minus square root divided by 2. Do I have everything I need to use this formula right now?
Yeah.
Okay. We need to decide whether it's the positive or the negative. I didn't tell you what quadrant s over 2 was, but I gave you some information about s, didn't I? If you wanted to turn this into an s over 2, what would you have to do to it? Divide by 2. So pi divided by 2 would just be pi over 2. It's less than s over 2. 3 pi over 2 divided by 2. 3 pi over 4. So essentially what I did is took all this times a half, so I could have my s over 2. If you are between pi over 2 and 3 pi over 4, quadrant 2. So s over 2 is in quadrant 2. Is sine positive or negative in quadrant 2? Positive. So we're going to go with the positive. Square root 1 minus the cosine of s, negative 3 over 7s plus 3 7s. Okay, what do you want to do? Yeah, I mean we can work this out by hand, you can use your calculator, whatever. 1 plus 3 sevenths divided by 2. It's going to be a fraction. No, because we decided we're in quadrant 2 and sine should be positive in quadrant 2. So you get 5 sevenths, is that right? Oops. So I need to erase that plus or minus. Don't want to leave a radical in the denominator. That's radical 5 over radical 7. So if you just multiply, you get radical 35 over 7. There's sine of s over 2. So now let's do cosine of s over 2. What's the formula for cosine of s over 2?
1 cosine radical 1 plus cosine A.
So very similar, except it's a plus. Alright, pick the positive or the negative. S over 2 is in quadrant 2. Cosine is negative in quadrant 2. So 1 cosine was negative 3/7, so minus 3/7, all divided by 2. So if you split that up, get your radical off the denominator, get negative radical 14 over 7. Alright, so we've done sine and cosine. Now we need tangent of s over 2. We have lots of ways of getting the tangent. We have 3 formulas.
I think we should do the one with the
I think we gotta do that.
Either one. We would have to find sine of s, wouldn't we? So I didn't give it to you. But we could do that. We could draw a triangle. We could use the formula with the radical because we have the cosines. You'll just have to deal with the radicals. Or, we've already found both sine and cosine, haven't we? Could we just divide those? Yeah. So 4 options there. Which one do you want to do?
the last one.
Yeah, I think that would be the shortest. So we're just going to take the ones we've already found and divide them. So we get radical 35 over 7 over negative radical 14 over 7. So either flip and multiply or take everything times the 7. And we get radical 35 over radical 14 negative. Okay, they're both under radicals, so we could reduce. What goes into both 35 and 14?
7.
So if you divide them by 7, we get negative radical 5 over radical 2. Get the radical off the denominator. Alright, all we're really being asked to do here is practice using your formulas. Find a formula that looks close to this. So you're looking at your flip chart, you have plus or minus the square root of 1 minus cosine something over 2. Which formula does that look like? Okay, so let's write down our formula. So sine of a over 2 equals plus or minus square root 1 minus cosine a over 2. Alright, so I gave you the right hand side of the formula. You're going to give me the left. So we need to figure out what our a is. Yep, a is 8x. So this is the sine of 8x over 2, which is, so sine 4x is our final answer. So just practice recognizing formulas. So B, what does that one look like? Tangent. So let's write down our formula. Tangent of a over 2 equals plus or minus square root 1 minus cosine a over 1 plus cosine a. So what is a? 9 beta. So this is tangent 9 beta over 2. Does that reduce at all? You can make it 4.5 beta